Hey everyone, this video is about the heating and cooling curve of water, or just any substance in general. So I just wanted to go through and explain this to you guys. All right, so on this diagram, we can call this like a little staircase diagram because you have the diagonal lines and then you have the flat lines, which would be like the top of a step. So along the diagonal lines, you only have one state of matter. So this bottom diagonal line represents solids heating, and then we have liquids heating, and then gases heating. The flat line represents a phase change. Okay, so when you have a solid and a liquid present, then this line is flat. When you have a liquid and a gas present, then this line is flat. Now, the diagonal line means that there's a temperature change. The flat line means that there's no temperature change. So if you think about the freezing point or the melting point of water, it's 0 degrees and that does not change until there's only liquid water present. If you think about the boiling point of water, it's 100 degrees. And then once there's only a gas present, then we have an increase in temperature again. I also want to compare this to kinetic and potential energy. On all the lines where the temperature changes, that's a kinetic energy change. And if you remember, kinetic energy is the motion of particles, so how fast or slow they're moving. So if there's a kinetic energy change, that means that those particles are moving faster, faster, faster. Okay, so when there's only a solid present, those particles start vibrating more and more and more as they're being heated or absorbing energy. And then at a certain point, they stop moving faster. They stick at the same speed, and instead, they start moving apart from each other. This happens during a phase change. And when they're moving apart, you have both solids and liquids present. So the fact that they move apart, that's a potential energy change. So along this diagonal line, we have a kinetic energy change. Flat line, we have a potential energy change. Then once there's only liquids present again, the particles stick at a particular distance and they start moving faster, faster, faster again. So we see this diagonal line. Then at a certain point, instead of moving faster, 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 they move apart, apart, apart. And then we have that potential energy change here. And then again, once there's only one state of matter present, it moves faster again. So finally, just as a review, you have a kinetic energy change on these diagonal lines. It represents the fact that those particles move faster. During a phase change, so melting or evaporating, or if it was a cooling curve, it would be condensing or solidifying or freezing. Those particles are moving apart or closer together, depending on if it's heating or cooling.